Before there was time, before there was light, there was the void. And within it, a cosmic cradle, a vast, cold, dark cloud of interstellar gas and molecular dust. A disturbance, perhaps a nearby supernova, sent a shockwave through it, and a pocket of this cloud began to collapse under its own immense gravity. At the spinning center of this collapse, a protostar ignited. 99.8% of all matter in the cloud was drawn into this gravitational furnace, becoming our sun. The leftovers were flattened by rotation into a vast, spinning plate of debris, the protoplanetary disk. For millions of years, this disk was a violent construction zone. Tiny grains of dust, coated in ice, stuck together. Static electricity built pebbles. Pebbles became boulders. And through a process called accretion, gravity molded these boulders into planetesimals, mountain-sized chunks of rock and ice. This was the age of Titans. These planetesimals, numbering in the millions, smashed into each other in a chaotic, fiery ballet. Worlds were built and destroyed in millennia. Out of this fiery forge, the survivors grew, their surfaces molten magma oceans, their orbits slowly clearing. From this chaos, 8 worlds would eventually emerge. This is their story. Our story begins where all life in this system begins. The sun. We pull back, accelerating past the innermost world. 2 scorched rock we will visit soon. Mercury and Venus. We continue outward through the incomprehensible void. And then ... we decelerate. We approach the 3rd orbit, and a familiar shape emerges from the blackness. A swirl of blue, white, and brown. A world unique in the known universe. This is home. Earth. From this vantage point, it appears fragile. A precious marble of life suspended in the hostile emptiness of space. Its continents, its oceans, its swirling atmosphere. All the result of a precise and delicate cosmic balance. But its familiar face is just that ... a face. A thin crust. We live on the cooled skin of a raging furnace. The true secrets of our world, and all worlds, lie not on the surface, but deep within. What truly makes a planet live or die? To understand what makes a planet tick, we must look under the hood. To truly know a world, we must perform an anatomy. We must peel back the crust, the thin, brittle shell that separates us from the inferno below. We must dive deep into the mantle, the vast ocean of solid, yet flowing, hot rock that drives the continents ... and slice all the way to the heart. The core, a sphere of iron and nickel, glowing hotter than the surface of the sun. A liquid outer core, spinning to create the magnetic shield that protects us. And a solid inner core, a monument to the planet's birth. To understand our place in the cosmos, we must first look inside. This is the solar system, an anatomy. Our journey begins at the frontier of the inner solar system. We decelerate from warp, the sun blazing with unimaginable intensity. This is the domain of Mercury, the swiftest planet, a tiny world of iron and rock, utterly scoured by its star. We drop low, racing over a surface that looks like our own moon. It is a dead, gray landscape, a fossil record of the solar system's violent youth. The sky is not blue, but pitch black, studded with stars, even in broad daylight. The largest scar of all, the Caloris Basin, a 1,500-kilometer wide impact crater, looms on the horizon. Here, the sun is a relentless tyrant, appearing 3 times larger than on Earth. With virtually no atmosphere to protect it, the surface is baked by scorching radiation, reaching 430 degrees Celsius, 800 degrees Fahrenheit. Lead would melt into a puddle at your feet. But Mercury's day is long 176 Earth days for one solar cycle. As the sun finally sets, the planet's night side is exposed to the vacuum of space. With no atmospheric blanket to hold the heat, it plunges into a cryogenic freezer, a frigid negative 180 Celsius, minus 290 degrees Fahrenheit. A 600-degree temperature swing. And yet, in this impossible place, a miracle. We move to the poles, into deep craters that are permanently shadowed, places where the sun's rays never touch. And there, confirmed by radar, are massive deposits of water ice. Billions of tons of it, likely delivered by comets and asteroids, have survived for eons in this frozen, eternal darkness, just a few kilometers from the inferno. As we orbit, we see massive cliffs, or scarps, that crisscross the planet. These are not canyons, but wrinkles. They are proof that as Mercury's massive core cooled over billions of years, the entire planet shrank, its crust buckling and folding like the skin of a drying apple. But this surface is just the wrapping paper. The true nature of this planet is a secret it keeps hidden deep inside. To see it, we must phase through. We accelerate towards the surface, and the rocky crust becomes translucent. Flying through the thin, dark, silicate crust and the equally thin, rocky mantle. On Earth, the mantle is dominant. Here, it's just a sliver. Because we almost immediately strike ... metal. A colossal, shimmering, molten ocean of it. This is Mercury's core. We plunge into the liquid iron nickel, swirling slowly from the planet's rotation. We stop at the center, hovering before the small, solid inner core. The anatomy is shocking. The crust and mantle are just a thin shell. His single massive sphere of iron and nickel makes up 85% of the planet's entire volume. Mercury is not a rock planet. It is a metal cannonball wrapped in a thin veneer of rock. How? The giant impact hypothesis suggests a young, larger Mercury was struck by a massive planetesimal. We pull back, phasing out into space. And incredibly, this ancient heart is not dead. Our visualization shows that at least the outer part of this massive core is still molten. That churning of liquid metal ... generates a magnetic field. But it is weak only 1% as strong as Earth's. As the solar wind slams into it, our visualization shows the field being battered, compressed, and crushed close to the planet. It is a tiny, defiant shield, a ghost of a dynamo. Mercury is a contradiction, a dead surface hiding a dynamic liquid metal heart. From this scorched anomaly, we now travel to a world that should have been our twin ... but became a vision of hell. We leave the scorched rock of Mercury and travel outward to the second planet, Venus. From a distance, it is a jewel, a serene, brilliant white-yellow sphere, almost identical in size to Earth. It looks peaceful. But this beauty is a lie. It is an impenetrable mask. As we descend, we are not met with water and air, but with a 20-kilometer thick blanket of clouds made not of water ... but of corrosive sulfuric acid. Plunging through this acidic fog, the pressure begins to build. The light fades ... and then we break through the cloud deck. Into hell, we have landed on Venus. The air is not air. It is a 460 degrees Celsius, 900 degrees Fahrenheit supercritical fluid. A crushing atmosphere, 92 times heavier than Earth's. The pressure is equivalent to being 1 kilometer deep in our ocean. The landscape is a panorama of volcanic devastation. Vast plains of basalt, rivers of lava, and giant shield volcanoes. This entire planet was resurfaced by a cataclysmic, globe-spanning volcanic event 500 million years ago. Above, the sky is not blue, but a sickly, oppressive orange, thick with sulfur. In the upper atmosphere, lightning, perhaps thousands of times more frequent than on Earth, rages constantly. The extreme heat and pressure are so intense that the Soviet Venera probes that landed here in the R-1980s survived for less than 2 hours before being melted and crushed. This is not a world for life. To truly see Venus, we must use radar. Peeling back the clouds reveals a world of continents and mountains. We see Ishtar Terra, a highland the size of Australia, and Aphrodite Terra, the size of Africa. We even see metallic snow, likely vaporized lead, that has condensed on high, cold mountain peaks. But as we pull back, the radar fades and the beautiful, deadly clouds return, hiding the horror. This is Earth's twin, a paradise that took a wrong turn, and the reason lies in its heart. We accelerate towards the planet, plunging through the acid clouds. We break into the hellish atmosphere and phase directly through the volcanic surface. We are flying through the crust and into the massive rocky mantle. It is hot, glowing a dull orange, but unlike Earth's, it's sluggish, barely moving. Let's look inside it. We push deeper and enter the core. On paper, it is a perfect match for Earth's, a large iron-nickel heart. But look, Earth's core was a swirling, dynamic engine. This core is static. It's dead. While the outer part is likely molten, there is no convection, no movement. The dynamo is silent. We pulled back, phasing out of the dead planet and into space. And that is the fatal difference. Our visualization shows Earth's swirling core, creating a protective magnetic shield. Beside it, the visualization for Venus shows nothing. The core is static. The shield is gone. Without a magnetic field, the solar wind slammed into Venus for billions of years, stripping its atmosphere and boiling its oceans, turning a paradise into an inferno. We now leave this toxic wasteland and set course for home. We leave the suffocating hell of Venus and make for the third orbit. A familiar world comes into view. This is home, Earth. From space, it is the most beautiful object in the known universe. A living, breathing planet. A dynamic world of moving water, swirling clouds, and shifting continents. As we cross into the Terminator, the night side reveals a new kind of illumination, the electric webs of human civilization. At the poles, the sky comes alive. This is the aurora, the only visible part of an invisible battle where our planet's defenses meet the fury of the sun. All of this, the air, the water, the life, is possible for one reason. Life is everywhere. It thrives in the most extreme places, from the calm eye of a raging hurricane to the crushing, dark depths of the ocean, where vibrant ecosystems flourish on coral reefs. Life has sculpted this planet. It blooms in complex symmetry. It takes flight on pollinated wings. It blankets continents in vast, green rainforests that act as the lungs of the planet, and it roams vast savannas. Earth is a planet of water, existing in all three states. It is frozen in massive ice sheets that grind continents. It is liquid in the vast oceans that regulate our climate. And it is vapor in the deserts, creating heat mirages. This is not a dead, static world. It is geologically active. Volcanoes recycle the planet's crust, bringing new land from the mantle. Thunderstorms harness electrical energy. And on this stage, one species has emerged that can observe it all. Humanity? We build, we dream, we explore. We are the planet made self-aware. And all of it, the oceans, the atmosphere, the cities, the very thoughts in our brains, exist only because of what lies deep inside. We have seen this in our introduction. Now, we perform the full anatomy of our home. We plunge from orbit, straight into the Pacific Ocean. We are flying through the thin oceanic crust and into the massive glowing orange mantle. Unlike the sluggish mantles of Mars or Venus, this one is alive, visibly churning in massive, slow-motion convection currents that move the continents above. We fly deeper, the outer core. It is a violent, raging storm of liquid iron and nickel, swirling hotter than the sun's surface. This liquid inferno rages around a solid heart, the inner core, a perfect sphere of solid iron, compressed by unimaginable pressure. This is the dynamo. This is the engine of our world. We pull back, phasing out through the layers and back into space. This combination, a solid inner core and a churning liquid outer core, driven by the planet's rapid 24-hour rotation, creates the most important thing we have ever seen. Our visualization shows the dynamo generating a colossal magnetic field, the magnetosphere. This is the secret to life on Earth. This invisible shield, which Venus and Mars lost, is our guardian. The visualization shows the solar wind, a deadly stream of radiation, being deflected harmlessly around our planet, protecting our fragile atmosphere. The aurora we saw is the shield in action, a visual reminder that our planet's fiery, dynamic core is the only reason our blue, tranquil surface can exist. We now leave the safety of this shield and head to a world that lost the fight. Our next stop, Mars. We leave the safety of Earth's magnetic shield and push outward to the fourth planet, Mars, the red planet. For all of human history, this was the god of war, a symbol of fire. In reality, it is a frozen, rusty relic. As we get close, its wounds are visible. We descend into Valles Marineris, the Grand Canyon of Mars. This is not a canyon carved by water. It is a colossal tectonic crack, a scar in the planet's crust, 4,000 kilometers long. We exit the canyon and fly towards the Tharsis region, home to the largest volcanoes in the solar system, Olympus Mons, a shield volcano 3 times the height of Mount Everest, and so wide you could not see the slopes from its summit. A monument to a time when Mars was geologically active. We land, joining our robotic explorers on the surface. The world is red, silent, and cold. The sky is a thin, pinkish haze. The sun is small and weak. At dusk, a haunting blue sunset appears as fine dust scatters the blue light. This is a world of dust. Planet-circling dust storms can blot out the sun for months. A terrifying, dark red maelstrom that coats everything in a fine, iron-rich powder. But our rovers have found the truth. This is not just a rock. Grinding into the surface, we find sulfates, salt deposits, unmistakable minerals left behind by water. And then we see it. The proof is everywhere. Spherical blueberries that could only form in water. Dried river deltas. Vast plains of sedimentary rock laid down layer by layer at the bottom of an ancient lake, or perhaps an ocean. "4 billion years ago, Mars was not red, it was blue. It had thick air, clouds, and rivers. The polar caps, a beautiful swirl of water, ice, and dust, are the last frozen remnants of that lost, wet world. So what happened? To find the killer, we must look for the body. We phase through the surface. We fly through a thick, cold, rigid crust and into a dormant mantle. It's sluggish, cold, and solid in most places. We continue to the center. We find the core. It is small, and it is different. It's not the pure iron of Earth. It's a dirty iron-sulfur mixture. The sulfur acts like antifreeze, keeping the core liquid, but also making it less dense and less dynamic. Our instruments can feel it, a faint heartbeat. It is still partially liquid, but it's sluggish, dying. In a flashback, we see its past, a fast-spinning, energetic dynamo, like Earth's. But now, it's fading. Mars is smaller than Earth. It cooled down faster. Its heart, the engine that powered a living planet, seized up and died. We pull back, phasing out of the dead world. In this visualization, we see what Mars once had. Its core was spinning, its dynamo was active, and it had a strong magnetic field. That shield protected its thick atmosphere and its vast liquid water oceans. Mars was a living blue world. For billions of years, it has been sandblasting Mars, stripping its atmosphere, molecule by molecule, into space, boiling its oceans, and leaving behind the frozen red ghost of a world we see today. We now leave the inner planets and head for the realm of the giants. We leave the realm of the rocky planets and cross the asteroid belt into the domain of the giants. We decelerate and are met not by a planet, but a king, Jupiter, a failed star, a colossal ball of gas and liquid, 1,300 times the size of Earth. Its surface is a raging, chaotic tapestry of storms. The most famous, the Great Red Spot, is an anticyclone, a storm wider than 2 Earths. That has been raging for at least 300 years. This is a true system. Jupiter has faint, dusty rings and over 80 moons. A miniature solar system in itself. Its moons are worlds of their own. The volcanic moon, Io, is the most geologically active body in the solar system. The ice moon, Europa, hides a global liquid water ocean, a prime candidate for life. We move to the poles, and the view becomes a work of art. As seen by the Juno probe, Jupiter's poles are not banded, but are a stunning, turbulent cluster of geometric cyclones, swirling in a deep, vibrant blue. We now take the plunge. We dive into the atmosphere. We first pass through a layer of white, freezing ammonia ice clouds. Then, a darker, brownish layer of ammonium hydrosulfide. And deeper still, a turbulent, dark layer of water ice and liquid water clouds. This is the weather layer. Colossal lightning bolts, 1,000 times stronger than Earth's, flash in the darkness. Strange, slushy mushballs of ammonia water hail fall. As we descend, the pressure builds and the gas becomes an impossibly thick, dark, hot fog. Back in orbit, we see the power source, the auroras. Generated by an unimaginable magnetic field, these lights are brighter than the sun and cover an area larger than our entire planet. Jupiter's most defining feature is its speed. It spins once every 10 hours. This incredible velocity stretches its clouds into the bands we see, and it is the key to understanding its heart. We plunge again. We dive through the gas, deeper and deeper, until the pressure, 1,000 times that of Earth, becomes so great the gas becomes a liquid. There is no solid surface. We are now flying through a dark, strange ocean of liquid hydrogen. We descend for thousands of kilometers through this ocean until the pressure becomes millions of atmospheres. And then, the impossible happens. The hydrogen itself changes. The pressure is so great, it forces the electrons from the hydrogen atoms, and it begins to conduct electricity. We are now flying through a vast, swirling, golden ocean of liquid metallic hydrogen. This exotic substance, which does not exist on Earth, is the engine of the planet. Finally, we reach the center. There is no solid core. Instead, scientists now believe is a fuzzy core, a dense, hot, dark slush where, over millions of years, the planet's original rock and ice have dissolved into the metallic hydrogen, a heart of stone dissolved in a sea of metal. We pull back, flying out of this strange, fuzzy heart, back through the golden sea of metallic hydrogen, back through the dark liquid ocean, back through the crushing gas, and into space. This is the anatomy of a gas giant, no solid ground. And that layer of liquid metallic hydrogen, combined with Jupiter's 10-hour rotation, creates the most powerful dynamo in the solar system. It generates a magnetic field 20,000 times stronger than Earth's. This field traps a lethal donut of radiation and plasma, fed by the volcanoes on its moon, Io. Jupiter is a king, a protector, and a monster. Its gravity shields Earth from comets, but its radiation would kill any unprotected human in minutes. We leave this giant and move on to the jewel of the system. We leave the chaotic kingdom of Jupiter and travel outward to the true jewel of the solar system, Saturn. If Jupiter is the king, Saturn is the work of art, a serene, pale yellow giant defined by a structure of breathtaking beauty. Its rings, a disk system so vast it would almost fill the space between the Earth and our moon, yet in most places it is only a few dozen meters thick. Like Jupiter, Saturn is a mini-system. Its moon, Enceladus, a tiny ball of ice, shoots massive geysers of liquid water into space from a subsurface ocean. And its largest moon, Titan, is a world unto itself. But first, we must explore the rings. We fly directly into them. They are not solid. They are a blizzard, a flowing river of billions of individual chunks of pristine water ice, from the size of dust particles to the size of mountains, each in its own individual orbit. They are the remnants of a shattered moon, or perhaps a comet that strayed too close, torn apart by Saturn's gravity. We fly through the Cassini division, a massive gap in the rings, and head for the planet itself. At the North Pole, we find one of the strangest wonders of the solar system, the hexagon, a six-sided jet stream, a storm wider than two Earths, rotating with perfect geometric stability, a mystery of fluid dynamics we still don't fully understand. Van Ben MCC Hun, we now visit its giant moon, Titan. We plunge through its thick, Orange, nitrogen smog atmosphere, a chemical soup similar to early Earth. We break through the haze and find a familiar world. Rivers, lakes, and seas. But this is not an oasis. The temperature is negative 180 degrees Celsius. The mountains are rock-hard water ice. The rivers are not water. They are liquid methane, carving channels to a methane sea. We ascend from this bizarre, cold, alien Earth and return to Saturn itself, a world far less turbulent than Jupiter, but one that hides a similar engine. We phase through the pale yellow ammonia clouds. Like Jupiter, Saturn has no solid surface. We dive through the thick hydrogen gas. The gas transitions into a vast ocean of liquid hydrogen. Deeper, the pressure ignites it into a swirling golden ocean of liquid metallic hydrogen. This is Saturn's dynamo. But Saturn is colder than Jupiter. We see a unique phenomenon, a rain of liquid helium, which has condensed out of the atmosphere and is falling through the metallic hydrogen, generating heat. We push through this rain, and we find a heart. Unlike Jupiter's fuzzy core, Saturn's is more defined. A solid, dense core of rock and ice, 10 to 20 times the mass of Earth that the planet originally formed around. We pull back, phasing out of the ringed planet. Our anatomy is complete. The visualization shows Saturn's layers, including its solid core. Its swirling metallic hydrogen, though smaller than Jupiter's, creates a powerful magnetic field. This field, as our visualization shows, is interacting with the rings. It creates dark, mysterious spokes that sweep across the rings. More importantly, it funnels icy particles from the rings down into the planet's atmosphere. This is ring rain. It is a process that is actively eroding the rings. In 100 million years, a mere blink in cosmic time, Saturn's most glorious feature will be gone. We are lucky to see them. We now leave this jewel and head for the strange sideways worlds of the outer darkness. We leave the majestic system of Saturn and begin the long, cold, dark journey to the outer solar system. We arrive at the seventh planet, Uranus. This is not a gas giant. This is an ice giant. Immediately, we see something is wrong. The planet is rolling like a barrel, not spinning like a top. It has been knocked over onto its side. Its faint, dark rings are vertical. Its moons orbit up and over the planet. The entire system is tilted. Its moon Miranda is a testament to a violent past, a chaotic jumble of cliffs and canyons, as if it were shattered and poorly reassembled. We move in to this strange sideways world. The planet itself is quiet, eerily quiet. It is a pale, cyan blue, featureless sphere. There are no giant storms, no chaotic bands, just a cold, hazy, silent atmosphere. Because of its 98-degree tilt, its seasons are extreme. Each pole experiences a summer of 42 continuous years of sunlight, followed by a winter of 42 years of total darkness. We descend into the atmosphere. We pass through a top layer of methane ice clouds, which give the planet its blue-green color. Deeper, we find clouds of hydrogen sulfide. Uranus, uniquely, smells like rotten eggs. This is a dark, cold world. Its rings are not made of bright, reflective ice like Saturn's, but are dark as charcoal, made of irradiated rock and dust. The whole planet feels like a ghost. It's cold, it's quiet, and it's sideways. But this quiet exterior hides one of the most bizarre interiors in the solar system. We phase through the cyan haze. We dive through the hydrogen and helium atmosphere. But unlike Jupiter or Saturn, the pressure here is not high enough to create metallic hydrogen. There is no dynamo of liquid metal. Instead, the gas abruptly dissolves into something else. We are flying through a vast, dark, swirling ocean. This is the planet's mantle, a bizarre slush of ices, water, methane, and ammonia. At these extreme pressures and temperatures, this ice isn't solid or liquid. It's a superionic fluid, a strange, electrically conductive, salty ocean. We fly through this massive, dark, superionic ocean, and at the very center, we find a surprisingly small, solid core of rock and ice. This is the anatomy of an ice giant, a small, rocky core wrapped in a massive, turbulent mantle of slushy ices, which is then wrapped in a thick gas atmosphere. We pull back, phasing out of the sideways planet. Our visualization shows this anatomy, and it reveals the source of Uranus's magnetic field. It's not the core, it's the mantle. That swirling, salty, superionic ocean of ice is what generates the field. And because the dynamo is a swirling shell, not a central core, the resulting magnetic field is bizarre. Our visualization shows it is not centered. It's offset by 1/3 of the planet's radius. A flashback visualization shows a young, normal Uranus being struck by an Earth-sized protoplanet. The cataclysmic impact knocked the entire world, and its future, sideways. We now leave this broken giant for the last true planet. We leave the strange, sideways ghost of Uranus and push on to the very last true planet. We arrive at Neptune. Immediately, it is different. It is not pale cyan. It is a deep, vibrant, ultramarine blue. And it is alive. Unlike Uranus, Neptune is racked by storms. The Great Dark Spot, a colossal hurricane the size of Earth, rages in its atmosphere, accompanied by fast-moving, white scooter clouds. This world has faint, clumpy rings or arcs, and it has a truly bizarre moon, Triton. It is a large, icy moon that orbits the planet backwards, a clear sign of a violent past. Neptune is a world of impossible violence. It has the fastest winds in the solar system, raging at over 2,000 kilometers per hour, nearly twice the speed of sound. We descend into its atmosphere. Like Uranus, it's a layer cake of methane ice, then hydrogen sulfide, then a slushy, dark water ice layer at the bottom. But the real show is its moon, Triton. We fly low over its pinkish, frozen nitrogen surface, which has a bizarre texture like the skin of a cantaloupe. And then we see them, cryovolcanoes, ice geysers. Powered by faint sunlight, these plumes erupt, shooting dark nitrogen gas and dust 8 kilometers high, staining the polar ice cap. This strange, backward-orbiting moon, combined with the planet's violent storms, points to a chaotic system. But why is it so stormy, so far from the sun? We phase through the deep blue atmosphere. We are on an ice giant, so the anatomy is similar to Uranus. We fly through hydrogen and helium. The gas transitions into the vast, dark ocean of the ice mantle, a slush of water, methane, and ammonia. But here is the critical difference. This mantle is not cold and quiet. It is hot. It is glowing a dull red. It is swirling violently, a convecting superionic ocean. We reach the center, a solid core of rock and ice, similar to Uranus's, but our visualization shows this core is radiating intense internal heat, far more than it should. Neptune is boiling from the inside out. We pull back, phasing out of this surprisingly active world. Our visualization confirms the anatomy. Like Uranus, Neptune's dynamo is its hot, swirling ice mantle, which creates a bizarre, off-center, and tumbling magnetic field. But here is the key. Neptune radiates 2.6 times more heat than it receives from the distant sun. It has a powerful internal engine left over from its formation. This internal heat is what powers the supersonic winds and creates the giant storms. It is a living planet, while its twin, Uranus, is dead. And Triton? Our visualization shows it was a dwarf planet, like Pluto, that was captured by Neptune's gravity long ago. The capture threw the entire system into chaos, and its gravitational pull may even be what stirs Neptune's active interior. We now leave the last planet and head for the dark frontier. We leave the orbit of Neptune and fly on into the endless, cold darkness. We are now in the Kuiper Belt, the vast, icy graveyard of the solar system, where the sun is just the brightest star in the sky. This is the home of dwarf planets. Pluto, a complex world with a nitrogen ice heart. Its moon, Charon. And Arrokoth, a pristine, untouched relic from the dawn of our system, 4.5 billion years ago. Billions of these icy bodies wait in the dark. We now follow our most distant emissary, the Voyager 1 spacecraft, as it leaves this frontier behind. In 1990, it turned its camera around one last time to look home, and this is what it saw: a single pixel, a pale blue dot. Look at it, that is here, that is home. On it, everyone you love, everyone you know, everyone you ever heard of, lived out their lives on a mote of dust suspended in a sunbeam. We have dissected 8 worlds, 8 cosmic machines: the oversized iron heart of Mercury, the dead dynamo of Venus, the swirling, living engine of Earth, the cold, rusty ghost of Mars, the golden metallic ocean of Jupiter, the solid, ring-fed heart of Saturn, the sideways, tumbling ice giant Uranus, and the hot, stormy core of Neptune. Our anatomy of this solar system is complete. Voyager continues, crossing the heliopause, the boundary where the sun's influence ends and interstellar space begins. It carries a message, a golden record, a greeting to a universe we are only just beginning to know. Our journey of 8 planets ends, but the universe is not 8 worlds. It is billions of worlds, new stars, new planets, new anatomies, waiting to be discovered. The journey is just beginning.